Okay. So, Ms. Avantika, let's say we have the same car. Same car implies that the weight of the car is 13,350 Newton and the mass is 1362 kg at the bottom of a 25-degree hill. So this is 25 degree and the car would be somewhere at the bottom. Just for the sake of ease, I have put the car here. Ms. Avantika, is it making sense? The car is at the bottom.
Yes, sir.
It would be somewhere here, but just for otherwise the diagram would get very messed up. That is why I've chosen a point a bit above. A couple of kids push on the car with a combined force of 7250 Newton. So this is the force with which the kids are pushing the car up. Their combined force is parallel to the incline. So this force of the kids is parallel to the surface. Am I making sense?
Yeah.
What is the acceleration of the car? Now, because we have done few questions like this before, we understand that the weight of the car can be broken into two components. One would be this W sine cos theta component. This W cos theta component would be balancing the normal reaction. And the W sine theta component, this component would be parallel to the inclined surface and would be opposing the push of the kids. Am I making sense?
Yeah.
And I have to draw my frame of reference always so that I know which direction is positive, which direction is positive. In my frame of reference, this direction in x is positive and this direction in y is positive. Am I making sense?
Yes, sir.
The thing that we were discussing was that if this force of the kids is less than this component of W, then the car won't move up. But we calculate this W sine theta component. The W sine theta component is 5642 Newton, which is less than this 7250 Newton component of the force of the kid. That is why the car will move up. Are we clear?
Yeah.
So if I apply the mother equation, sigma f is equal to ma in the, let me, actually what I'll do is, in my frame of reference, what I'll do is, just for an ease, I will consider this direction of x to be positive. So that my equation becomes 7250 minus 5642 is equal to mass into acceleration. Avantika, have you understood this equation, what I have done?
Huh.
So now what I need to calculate is 7250 minus 5642 is equal to 1608 divided by 1362, which would be equal to 1362, which will be equal to 1.18 meter per second square. Is it making sense?
Yeah.
The kids are pushing the car for 20 seconds and the initial velocity is zero. Why? Because they have said that the car is at rest at the bottom and they want us to calculate how far. So ut plus half at square is equal to 0 plus half a t square. Whatever is the answer would be the answer which will be written here. Is it making sense?
Yeah.
Uh, I will just draw a force diagram for this question. You'll have to do the calculation yourself. Box on the frictionless ramp is held at rest by a tension force. Frictionless ramp is held at angle theta. So maybe this is how this block is being held. Am I making sense? This is the
Yeah.
this should be straight line. Just mind it. This should be a straight line like this. Okay, now if I have to draw the free body diagram, let me draw the diagram here. So this will be the weight of the box. It is a frictionless ramp. It is held by a tension. Mass of the box is 20. Force diagram determine the value of the tension force. W is equal to mg is equal to 20 into 10. I'm assuming it to be 10 meter per second square. So this is W. This is theta. I can break the W in W cos theta and W sine theta. See, in this case, the box is not moving because it is held by this thread, and therefore the tension is in this direction. This is the T, and this T will basically balance the W sine theta component. Am I making sense?
Yeah.
So T would be equal to mg sine theta. They haven't given the value of theta. Yeah, if they would have given a angle of the value of theta, we would have put it here, and then we would have calculated the value of tension. Is Avantika, is it making sense? Miss Avantika, is it making sense? Miss Avantika, am I audible?
Yes, sir.
So what I'll suggest is I'll send you this PDF. Try to do these three questions again without looking at the solution. Would you be able to do that?
Yeah.
Okay.
Yeah.
Let's meet on Tuesday now.
Okay, sir.